Very good afternoon, students. Today I have come to discuss the solution of practice set 2, and these will help you a lot for cracking the various competitive exams like GATE, Isro, IAS, and many more, right? Okay, so I think it's very helpful to you, and you have already gave me the suggestions and encouragement, and but from my end I will definitely do something good for you, and I want that every one of EC third year would be capable to do a more better in future, and will be established, right? And so I think this will help you a little bit for cracking the competitive exams, because there are some procedures are slightly different. You will come to know various new formulas, various new techniques, and various new concepts, various new logics, and various procedures to solve any problem, right? And one more thing that I already told in my previous lecture, that is, all the questions are very simple, right? But it is presented in a complex way to get you confused, right? So you have to handle all the questions in your tricks, in your way, that no complexity can pull you from behind, right? And you will go to forward. So today I will discuss my practice set 2, and the PDF has already been shared with you, and I think every one of you have gone through the problem set, and also the solution is there. And now I am here to discuss the solutions in more lively, so that no confusions at your end, right? Okay, so today I will start discussing the practice set 2, and which is all about your information and coding theory, because I will concentrate my subject first, and then if you want to take preparations of any other subjects, please, the suggestions are always welcome for me, and if you think so, then I will arrange for you, right? Okay, so let's start. I have already shared the question set also, and but to consume my time, I will not write the questions in a full form, but I will write the important one, and then mainly concentrate on the solution, the way of solutions, right? And all the tricks, all the logics I have already highlighted in my question set, but now again I will focus on that points once more, right? Okay, so what was my question set? This was my, please don't see the answer, this was my question set 2, right? This was my first question. And what is the first question? Please go through the question. A discrete memoryless source has an alphabet A1, A2, A3 and A4, right? A1, A2, A3 and A4, and with the corresponding probabilities half, 1/4, 1/8 and 1/8, right? And the minimum required average code word length in bits to represent the source for error-free reconstruction is, right? And this has already come in GATE 2016, right? But I must say the question is very easy, but you have to identify the clue, right? You have to identify the clue. Okay, so here just now I will write some tricky points regarding that to solve the question. You have a source. I think it's visible. You have the source, and the source is defined by DMS, right? And this DMS has 4 symbols, 4 alphabet, right? And it's denoted by A1, A2, A3 and A4, right? Okay, and the probabilities is already defined. This is half, this is 1/4, this is 1/8, and also this is 1/8, right? Okay, and you have to calculate the minimum average code word length in bits to represent the source for error-free reconstruction, right? Okay, so please note it down. The minimum required average code word length. Here is the clue. Please spell the word again, the average, right? And please focus on the question that has been asked for, that the minimum required average code word length, this average code word length, this is the clue, right? So we have already known that how can you calculate the average information, right? And what will be the answer? The answer is nothing but entropy, because entropy is nothing but the average information contained per source symbol, right? So if we can calculate the entropy, and then we can easily answer that what is the minimum required average code word length in bits. It is always asked in terms of bits. So here is the clue, because the unit of the entropy is bits per symbol, right? So if you can calculate the entropy, then it will be represented in terms of the minimum required average code word length in bits, right? Okay, so the answer will be nothing else, the entropy calculation, right? So how can you calculate the entropy calculation? Please go to the formula, that is Hx will be, what is the how many symbols are there? I equal to 1 to 4. Just 1 minute. I equal to 1 to 4 p of xi log 2 1 by p of xi, right? Okay, so please put the value half plus, sorry, I am log 2 2 plus 1 by 4 log 2 4 plus 2 by 8, because the 1 by 8 is 2 times, that's why 2 by 8 log 2 8. Okay, and what will be the answer? This is half plus 2 by 4 plus 6 by 8. You can go to my answer sheet, and it is nothing but 1.75, right? And the unit is, what is the entropy unit? Is nothing but bits per symbol, right? So your answer is simply 1.75 bits per symbol, right? So please note it down, where is the clue? And the clue is that you have to calculate the minimum required average code word length. So average information is nothing but entropy, and it is already mentioned that you have to calculate the answer in bits. So you have calculated, this is the value of 1.75 bits per symbol. So this will be your answer. Very simple, right? But it is represented in a very complex way. So nothing complex, all are simple, right? Okay. So coming to my next problem, it's a very interesting problem. I think you are in same opinion with me. What is the question number 2? You see the question first. The question number 2 is, an analog based signal band limited to 100 hertz, right? Okay, 100 hertz is band limited. So the maximum frequency, that is FM and minus FM, this is equal to, so FM equal to 100 hertz, right? It's sampled at the Nyquist rate. So this is first clue. The samples are required in 4 message symbols that occurs independently with the probabilities P1 equal to P4 equal to 0.125 and P2 equal to P3. So P2 and P3 value are not given. You have to calculate the value, right? The probability value. The clues are given and you have to calculate the probability value. Then you have to calculate the information rate of the message source is. Okay, the answer is not given, you have to calculate, because the virtual calculator is there in your get answer screen online mode. So you have to calculate the value and put the value, because there are so many questions without any option. You have to calculate the value and put the value, right? Okay, so this is from that category. So what is given in the question? The question is that an analog based signal, that is analog signal, okay, and FM equal to 100 hertz. So these type of questions I have already covered in the class many times, and many variations are there, and this is also belongs to that, but slight confusion is there, that the P2 and P3 are not given. You have to calculate the value of P2 and P3, but the question is how, right? Okay, so first, according to my first point, the signal is band limited to 100 hertz, so FM is equal to 100 hertz, right? and it is sampled in Nyquist rate. It is sampled in Nyquist rate. Okay, so what is your sampling frequency? That is Fs equal to nothing but 2Fm according to Nyquist criteria. So 2 into 100, that is 200 Hz. Okay, so this is your sampling frequency. And sampling frequency is nothing but this is also your R, because you have to calculate the information rate. Information rate means the formula is capital R equal to small r into H. Right? Okay. Now, coming to the probability part. How many probabilities are given in the questions? This is P1 equal to P4 equal to 0.125. Right? But the probability is always less than 1 and the total probability must be 1. This is the main clue, because the total probability will be 1. So if we add in some equation for that, from this equation we can easily calculate the value of P2 and P3. Right? So there is a system that is generating the symbols in 4 probabilities, that is P1, P2, P3 and P4. But summation is equal to 1. Right? So what is the value of P1 and P4? Because P1 and P4 are same. This is equal to 0.125. So 0.125 means 125 by 1000, that is 1 by 8. Right? This is 1 by 8. So P1 equal to P4 equal to 1 by 8 and P2 equal to P3. So we can say that P3 equal to P2, right? Okay, so what will be your equation? The equation will be P1 plus P2 plus P3 plus P4, that is equal to 1, because the total probability is 1. Okay, now what is the value? 1 by 8 plus P2 equal to P3. So we can say, we can convert in terms of a single parameter, and we can write it down 2P2 or 2P3, anything. Okay, because P3 equal to P2, and again it will be your 1 by 8. Okay, so 1 by 8 plus 1 by 8 means it is 2 by 8. 2 by 8 means 1 by 4. So 1 minus 1 by 4 is equal to 3 by 4, right? So what is your 2P2? 2P2 will be equal to 3 by 4 and P2 will be equal to 3 by 4 into 2, that is 3 by 8. Right? So this is also the value of P3. So we have got all the probabilities value, and that must be less than 1. So this is 1 by 8, 1 by 8 and 3 by 8 and 3 by 8, right? So how can you proceed further? The mother formula, you have to calculate the information rate, that is R, right? But this R is already given from the Nyquist criteria. This is 200, the value of 200, but we have to calculate the H. H is nothing but, what is the value? Entropy calculation. So how can we calculate the entropy calculation? Entropy is nothing but Hx equal to, what will be the value? 2 by 8, because 2 symbols 2 times, right? So 2 by 8 log 2 8 plus 2 into 3 by 8 means 3 by 4 log 2 8 by 3. So how we can calculate this? 2 by 8 means 1 by 4 into 3, right? Because log 2 a cube. So this will be equal to 3 log 2 means 3 plus 3 by 4. Here it is log formula, log a by b formula, division formula. And what will be the formula? Log a by b equal to log a minus log b, right? So it will be equal to log 8 minus log 3. Okay, so if we calculate the value will be 1.811 bits per symbol. The unit is very important. Okay, so you have calculated the value of H, and what will be your information rate? The answer will be equal to 200 into 1.811, that is bits per second. And what is the value? 362.2. Okay, so this is your required answer. Okay, so all are given in the questions. You have to identify the most crucial points, and please continue according to that. You will achieve your goal, right? Okay, so I think up to this, no questions, no doubt, no confusion, right? Okay, so coming to my third question, that is also a get questions. And again, I am showing the questions because it's impossible for me to write down the question once again. And now the question is, an analog signal is band limited to 4 kilohertz. Same type of questions, but in slightly different way. Analog signal is band limited to 4 kilohertz and sampled at Nyquist rate. Okay, fine. So FM equal to 4 kilohertz and sample rate means Fs equal to 2 FM. Okay, fine. Samples are quantized into 4 levels. Do you know quantization? Do you know sampling? I think the answer is yes, because you have already studied the communication, analog communication, digital communication. So there is no confusion about that. What is the process of sampling and what is the process of quantization, right? So these two processes are basically used for converting an analog signal to digital signal, right? And sampling is for discretization the time axis, and quantization is nothing but the discretization of amplitude axis. So discrete in time and discrete in amplitude is nothing but digital signal, right? So here is the process is defined for that. And samples are quantized into 4 levels, means in the amplitude axis there are 4 steps. Okay, you have already calculated the step size, you have already calculated the signal to quantization noise ratio, you have already calculated the process of PCM, right? So all belongs to that category. The quantized labels are assumed to be independent and equally probable. So here the clue is behind that. The quantized labels are assumed to be independent and equally probable. Okay, so the label is 4, right? So this is the please concentrate on this graph. This is your analog signal. I have already shown in the graph also. This is the analog signal, right? So here it's your time axis. Here is your amplitude axis. Amplitude axis quantized into your 4 levels, right? So these 4 levels means the 4 parts of the symbols. Okay. Okay, and all the symbols are independent and equally probable. Independent and equally probable. So if it is equally probable, what will be the probability of that? Equally probable means 4 symbols. So the individual probability will be nothing but 1 by 4, 1 by 4, 1 by 4 and 1 by 4. If it's divided into 5 levels, it will be 1 by 5 according to 5 times of 1 by 5, 1 by 5, 1 by 5, 1 by 5, 1 by 5. And if it is 10 labels, then it will be 1 by 10 according to so on, right? Okay. So if we transmit 2 quantized samples per second, yes, this is the highlighted one. I have already underlined that part. That will be help you to solve the questions in a very tricky way. That if we transmit 2 quantized samples per second, right? So please concentrate on this unit. Sample per second, beat per second, beats per symbol, all are different units, different parameters, right? So here it's sample per second. Sample per second means this is nothing but the value of small r. I think it's clear to you because the unit is saying that the sample per second. So this is nothing but the value of smaller, right? Okay. The information rate is because you have to calculate the information rate. Okay. So I have already discussed all the clues in the questions. So I think it will be now easier for you to solve the question. So how you can solve the questions? What is the clue? Okay. So now information rate will be calculated. So my mother formula is R equal to R into 8, right? Okay, and the level is 4. So L equal to 4, right? Why this L equal to 4? You have to use this L equal to 4. I am showing. I have already shown in my practice set, but now I will explain it more convenient way to get to know the objective of L, right? You can use this. You may not use it. Okay. Okay. Now the 2 quantized per sample. 2 quantized sample per second. So R equal to 2. Clear? Because it's sample per second. So R equal to 2. Okay. Now you have to calculate simply capital R. Okay. So capital R means smaller into 8. So you have to calculate the value of capital H. So how we can calculate that? By a simple formula. Hx means pi log to 1 by pi, but here the 4 symbols, because there are 4 labels. 4 label means 4 symbols, and 4 symbols are independent. I am again writing the word that is independent and equally probable. Okay, so this is the clue. Independent and equally probable means this will be the value of I equal to 1 to 4 pi log 2 1 by pi, right? And all the value is 4, 1 by 4, 1 by 4, 1 by 4, 1 by 4, because there are 4 symbols. So this is about 4 by 4 log 2 4. So nothing but 2. And these hx you can easily calculate from the value of L, because the simple formula, what is the relation between your hx and L, I have already said it in my previous practice set 1, and again I am saying the formula, that is, and this will save your time at the time of examinations, right? So hx you can calculate in one line, that what is the value of hx if you know the value of capital L, and what is the formula, this is nothing but log 2L. Okay, L equal to 4, so log 2 4 log 2 2 square, so nothing but 2. So you can calculate the value of hx in two different ways. If you want to save your time, then go in this way, and if you have enough time, then go in this way, right? Okay, so you have calculated the value of hx, you have calculated the value of r. So what will be your r information there? That is nothing but r into h. So this is nothing but 2 into 2, that means 4 beats per second, right? Clear? I think up to this, no confusion, no doubt. Okay, okay. So coming to my next part. What is my next part? Now, what was my next questions? What was my next questions? Yes. Now, my next question is the question number 4, right? Okay, so please see the questions. A source produces 4 symbols with the probabilities of 1/4, 1 by 8, 1 by 8, right? For this source, a practical coding scheme has an average code word length of 2 bits per symbol. And what will be the efficiency? I think it's a very simple questions, but in other way, in different way. So what is saying? A source produces 4 symbols with the probabilities. 4 probabilities are there. For this source, a practical coding scheme has an average code word length of, please see the questions very carefully, average code word length of 2 bits per symbol. Again, I am saying average code word length of 2 bits per symbol. So what is the value? Whose value is this? Average code word symbol. The unit is again bits per symbol. So it's nothing but hx. This is nothing but the entropy value, right? So coding scheme, okay. Now the efficiency of the code, right? So how can you calculate the efficiency of the code? Efficiency means the formula is hx by L, right? Okay, so you have to calculate the value of the average code word length. Okay, average code word length means, sorry, again one problem is there, is not entropy. Again, sorry, the average code word length, sorry, this is the length means the average code word length. Okay, so this is the value of L average, right? So this is the value of L average, average length. Okay, so what is my formula? Again I am writing over here. That is a source, 4 symbols. 4 symbol means half, 1/4, 1/8, 1/8, and the average code word length means L average equal to what is the value? 2 bits per symbol. 2 bits per symbol, and you have to calculate eta. Eta means hx by L. And how can you calculate hx? Hx will be equal to 4 symbols, so half log to 2, 1 by 4 log to 4, plus 2 by 8 log to 8. You have already calculated in a previous question also. So what is the value of hx? Hx is nothing but 1.75 bits per symbol. one another way you can easily calculate that whether the L average will be 2 or not, because in the question the unit is already given, see, bits per symbol, 2 bits per symbol. So this is the unit of L average, and you have already calculated the hx. Hx is also the symbol of bits per symbol, because efficiency, it has no unit, so the same units will be there. Bits per symbol are already cut down. Okay, so if you put the value 1.75 by 2, you can easily calculate that this will be 0.875 or 87.5%. But in your answer, there the option are 1, 7 by 8, half and 1/4. So how we can calculate? The simple way, if you calculate the hx in a fractional value, you will get the value of 7 by 4. So put the value of 7 by 4 divided by 2. So this is nothing but 7 by 8. Okay, so the answer will be 7 by 8, nothing else. Right? Okay, so this is a very simple question. Now, I am coming to my another question, that is the question number 5. And what is the question number 5? Please see that consider the discrete memoryless source with the alphabet S equal to S0, S1, S2, S3, S4 and dot dot dot. Okay, so there are infinity number of symbols. The respective probabilities are also there, dot 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 dot, right? So the entropy of the source in bit is nothing but very easy, but you have to use the formula of series formula that I have already shared with you. What will be your series formula and what will be that? Just go through the solution, because this is already enough explanations I have given in the PDF. So this is nothing but your hx, right? Hx will be equal to pi log to pi, simple. And hx means you have to calculate the entropy, so you have to calculate the hx, right? So pi log to pi, and there are so many symbols, so the limit will be I equal to 1 to infinity. So the half log to 2, 1 by 4 log to 4, 1 by 8 log to 8, 1 by 16 log to 16, 1 by 32 log to 32 and so on, right? Okay, and after this line, please see that this has become half into 1, 1 by 4 into 2, 1 by 8 into 3, 1 by 16 into 4 and so on, right? So we can represent this equation in terms of n into half to the power n. Please check it whether it will be applicable or not. If n equal to 1, then this will be 1 into half, just first parameter. Then n equal to 2, then this will be equal to 2 into 1 by 4, second parameter. Then n equal to 3, this will be equal to 3 into 1 by 8, third parameter. Then n equal to 4, so this will be equal to 4 into 1 by 16, fourth parameter. N equal to 5, then this will be equal to 5 into 1 by 32, fifth parameter, and it will be so on up to infinity. So we can series that, we can make a series, and the limit will be I equal to 1 to infinity n into half to the power n, right? And what will be the series formula? Please see about that, that if it's half to the power n, because you have already calculated the various formula, various properties in DSP, signal system and so on. And from there, if you see that part, that it is half to the power n, it is nothing but 1 by 1 minus half. Okay, and if we multiply n with this, and this is a differentiation property, and this property becomes half divided by 1 minus half a square. Right, so to solve the questions of information coding theory, you must have the knowledge of DSP, you must have the knowledge of mathematics, you must have the knowledge of signal and system. So all are correlated with each and other. So okay, so you have to concentrate each and every subject equally, right? So if we apply the formula of there, you can easily calculate the value, and this is nothing but 2 bits. Okay, so the answer is same, right? Okay, now okay, coming to my next question. Again, this is a question. A video transmission system transmits 6 to 5 6 to 5 picture frame per second. Here is the first clue. Picture frame per second, right? So whenever is the picture frame per second, so this is nothing but the value of small r. So small r will be equal to 6 to 5 per second, right? Each frame consists of this into this pixel grid with 64 intensity level, right? So L will be equal to 64. And so the data rate will be, data rate means nothing but r into r equal to r into h. Okay, so how can you calculate this h? I have already told that h is nothing but how the h and l is related. H will be equal to log 2l, right? And this rate will be multiplied by the pixel value also. So this will become 625 into 400 into 400 into log 264. Okay, so this is the total information rate, and the value will be equal to 600 into 10 to the power 6 bits per second. So 10 to the power 6 means megabyte per second. So you can easily calculate mbps. Okay, got it? It's a very simple. Okay, and these questions in various form come every year in GATE questions. So you have to gain the knowledge of that. It's a very simple question. Just find out the clue and just proceed with your answer. Nothing complex about that. Please go through the various questions that I am sharing with you in various forms, and it will help you a lot, right? So coming to my last question, and which is very lengthy questions. I am intentionally have given this question to you because this is IAS questions, and please see the question. A voice grade additive white Gaussian noise telephone channel has the bandwidth of this, right? Bandwidth means B equal to this one. Two-sided noise spectral density, that is eta by 2 equal to this one. Noise spectral density, you have already gained the knowledge about that in your analog communication noise chapter, right? So if you face any problem, please go through the noise chapter once again. It will help you to build knowledge about noise spectral density, noise figure, and noise filter related that, and noise related flicker noise, thermal noise, low frequency noise, everything, right? So please go through the noise chapter if possible. And the noise spectral density is defined as eta by 2 equal to this one. If the information rate is 52 kbps, is to be transmitted over the channel with arbitrary small bit error rate, then the minimum bit energy EB, right? So there is no option. You have to calculate the question answer and put this answer in the blank portion. So you have to calculate the value of bit energy. So here you will come to know, because this is a revised portion, I think this is already covered in your noise chapter in analog communication. So one subject relates so many subjects: DSP, signal system, mathematics, analog communication, digital communication, everything, right? So please try to focus on these subjects because these are the mother subject of your electronics and communication engineering. So please go through that, and here you will come to know the two very important formula, and by using that you will be able to calculate the value of the bit energy, right? Okay, so how can we proceed further? Because we will proceed with our mother formula of information encoding theory, because there is already noise, there is already bandwidth. So we will start our answer with a simple formula, that is C equal to B log to 1 plus S by N. It's a simple formula. Right? Okay, but in the question, the information rate is 52 kbps, right? And information is passing through the channel, right? So the channel capacity is already related to your information passing through, right? So if the information is more than information are going to pass through the channel, then the channel capacity will be more. But R is restricted by this formula, that is R less than equal to this one, because channel capacity nothing exceeded over that. So this is the formula less than equal to C. So C value is nothing but is related with your information rate. So we can put the value of 52 over this C, and the bandwidth is 4. Okay, so from there we can calculate the value of signal to noise ratio, that is 8.91. This is a ratio, so no unit will be there, right? And you have to calculate the bit energy. Okay, so energy means, what is the energy? How can you calculate work power energy? Go to your physics class in your 11, 12, 9, 10. You have already known that this work power energy chapter, this is a very important chapter, and from that concept we can calculate the energy. Energy means the power into time, right? So this is your signal to noise ratio. So this signal power into time, and time means nothing but this t and bit rate is related with inversely proportional. So t will be replaced by rb, 1 by rb. In similar way, the time and frequency are related, right? So s by n is already related with 8191. We have already calculated the value, but from there you have to put the value of s. So how can you eliminate the noise power? Is nothing but eta into bandwidth. So this is the another formula. Noise power will be equal to noise power spectral density into bandwidth. So all the values are already given in the question. So please put the value, calculate the value of s, and please put the value of s over there. And bit rate already given 52 kbps. So 52 bit per second. If we want to convert, it will be multiplied by 10 cube. So if we put the value, we can easily calculate the bit energy. So many important formulas are there. You have to relate the formula, you have to know the formula to answer your questions. So I think after this portion will be very helpful to you, okay, to upgrade yourself, to update yourself, and to become compatible with any examinations through which you will be established in your future, right? Okay, so thank you for watching this video, and for next practice set, please stay tuned, right? Okay, thank you.